We've got a log here from Hanni1312. Hanni is flying a 4-inch alien. I think this is going to be the first 4-inch frame that we've seen on this thread. Probably shouldn't look too different, but who knows? Maybe think something will be different. It's also an alien. Yay! Gotta love the alien frames. 4x4, 5x3 props on 4S power and Cobra motors. And you say you almost toasted your motors while trying out G-Tune. I have to say, I have yet to see an auto-tune algorithm that like. Some of them just plain don't work, and some of them may damage your motors. Something G-Tune, I've heard people report that they run G-Tune and it raises the P gains, and they run G-Tune and it raises the P gains again. Now, bear in mind, I'm really exclusively in the clean flight ecosystem. I haven't ever flown Tau Labs or Open Pilot. I've flown a little bit of DJI stuff. Yeah, I have. I admit it. So it's possible, maybe it's even likely that there's a very good auto-tune algorithm out there yet, but so far I haven't met one that made me happy. Maybe with Betaflight now we don't have to worry so much about auto-tune because Betaflight flies so good already on the defaults. I don't know. Anyway, let's just take a look at your config dump. I'm going to go down and just briefly look at all this relevant stuff. You are on PID controller Lux float, and so we'll look at your pitch F, your float values, 1, 4, 15, 1, 4, 15, I see. I see that your roll and your pitch gains are the same. Normally that would raise a flag for me because normally I would expect to see your P gain on pitch to be higher and also your I gain on pitch than on roll. But two things here. One is that you were flying an alien frame and a 4-inch alien at that. And the alien is specifically designed to be very compact and very symmetrical along all axes. It's probably not perfectly symmetrical, but it's better than most. Okay, so that means that you're more likely to have those things be similar. And the other thing is that I did notice as we were scrolling through here that you've got a custom motor mix, and that also will cause your pitch and your roll gains to be more similar because they sort of take the difference out. So okay, fine. And then you've got your yaw gain 3.9, 0.9, and 0. Okay, fine. Let's have a look at your logs. I have pulled up your roll, pitch, and yaw PID here, and as I start to scroll into them, I can immediately see your yaw P term jumps out at me as potentially likely problematic. It is immediately oscillating. Now, I often see when we are at low throttle, just taking off, that you'll get some harmonics that will then go away as soon as you throttle up. So my first thought was that maybe this is some like harmonics or something that's going to go away. What happens is that as the motors spin faster, their frequency goes up, and as the frequency goes up, the vibrations that they create move further and further into the filtered range that is being cut off by the filter. Whereas when the motors are spinning relatively slowly at idle, their frequencies are lower, and so they're less filtered. So as I keep looking at this, though, it just keeps happening. So your yaw, and let's just go ahead and take your pitch and roll out of here now and just focus on yaw. We can see that yaw P term is constantly oscillating. It's constantly oscillating all the time. Okay, so this is a characteristic of high P gain, excess P gain, and we can't really judge very much about the rest of your tune, your I gain on yaw, or you've got your D set to 0, but your D gain, because the P is just it's way too high. So your P is around 3.9, and this is pretty extreme. I would cut that in half. Take your P gain on yaw down to 2.0 and see what happens there. But in order to get this kind of oscillation on yaw, you really have to have it way too high. Like it's reasonably easy to get oscillation on roll or pitch. A copter is relatively willing to move on those axes, but most of our copters have relatively weak yaw authority compared to roll or pitch. So in order to get oscillations like this out of yaw, you gotta be way over the line on your P gain. So definitely reduce your P gain. The other thing I want to point out is you notice that there's no D here. Where's your D? Even though D is 0, you should still have a trace for it. And the answer to that is that if we go over here, no, your D is set to 10, but your D yaw F is set to 0. So there used to be, I don't know if it's still there, but there used to be a thing, was it a bug? I think it might be a bug in Blackbox where if you had your float, your yaw float set to something, but you didn't have your yaw, your integer yaw set to something, then it wouldn't record the D term on yaw. And so maybe it's if either one of them is 0, it won't record it. But if you ever get a Blackbox log on LuxFloat and you do not have a D term on yaw, you need to go into the CLI and just manually set D yaw to anything. It doesn't matter because LuxFloat doesn't use that. Say that 10 times fast. Whereas here it's probably not being recorded, I would guess, because you've got this one set to 0. So that shouldn't be a problem. If you add any D to your yaw, you'll be fine. So now let's have a look at roll. Roll is usually the axis I like to look at first because roll is where usually more vibration prone than pitch. That may be less true on a symmetrical frame like an alien. They may be more roll and pitch, maybe more equally prone to vibration. But let's take a look at roll. And again, I'm going to be looking at the red trace, the P gain or the P trace, and just looking for how it's behaving, looking for oscillations, and I'm not seeing any sort of, I'm seeing it move around. That's normal, but I'm not seeing any sort of strong regular oscillations like we were seeing on yaw. Nothing about this jumps out to me. Starting to get a little more dynamic. Your flying is getting a little more dynamic. And now, so now we've got a roll, and we can see what might be some signs of excess P here. Let me just turn off that D because D is going just bonkers. Okay, so here we've got the P as you go into the roll here, and you can see that it's jumping around a lot. I think that's probably a sign of excess P on roll. Or if we saw that on pitch, it would be the same thing. But I'm a little hesitant to do that because in general, I think I've seen Betaflight be slightly more active on the P and the D term, and it doesn't seem to cause bad effects in flight. So what I would really, I mean, just looking at the traces and not looking at any flight video or actually flying the copter, this looks to me like excess P gain, and I would tend to think it needs to be turned down. But the real test would be anytime that you raise the throttle, like here, what does it do? So here you've gone to max throttle. What happens? Do we get any hard oscillations? We get a little bit of oscillation. See, here's the gyro. We can see the gyro moving up and down. There's a little bit of oscillation, but honestly, it probably isn't too bad. I'm guessing that if we look at that in the camera, that's not too bad. You might hear it. I think I would back this down a little bit. The thing is that you don't need to have P right tuned to the razor's edge of sharpness to have good flight characteristics. If your P is too, there's a gray area where your P gets low enough that your copter starts to fly just a little sloppy, and you're kind of like, why is it flying sloppy? And then you need to add some P gain, but you don't need to have it right on the edge. So if you punch like this and you get oscillations, I would think about adding some TPA, maybe, or reducing P. Yeah, see, we also had it back in that roll. We had those. So the fact that we had the oscillations in the roll, or the spikiness in the roll, that suggests to me that, I mean, the throttle wasn't very high there. So that suggests that maybe overall your P gain should come down a little bit, as opposed to if we only saw the negative behavior here when the throttle gets high, then we would maybe put some TPA in there to tune it out. Now here you cut the throttle. Thank you, good. And that's a good move. And you let the copter fall for some time, and then you raise the throttle. And I can't really judge how that worked because I can't see what the copter did, but I can look at the gyro trace, and really we would expect to see stuff on pitch more than, so let's look at pitch. During this move, we would expect to see the copter moving on pitch. So let's have a look. So we'll look at the gyro trace. You cut the throttle here. At the moment that you cut the throttle, the gyro trace doesn't substantially change what it was doing. Okay, so that means the copter remained, it was moving because the gyro trace is not zero, but it remained relatively stable. You haven't moved this stick at all. Now we can see that the gyro levels out and the copter's moving the other direction. Rather the gyro crosses the line. The copter is now moving the other direction. So it was pitching forward, and now it's beginning to pitch backward. And pitching backward slowly, and none of that has to do with your stick. But honestly, I mean, how bad is this? I couldn't really say, but I bet it's not that bad. It's not perfectly flat in the zero throttle, but I bet it's still pretty solid. That doesn't look too bad for me. Now here, kind of interesting what happened here. Here we have a sudden pitch forward, which the P term quickly moves to counteract. The I term is not doing, now this is very interesting. Notice that the I term is not doing anything because you're below min check. So here, the P term falls. The gyro rises, indicating that you're pitching forward, and the P term quickly moves to counteract it. But the P term is acting alone, and the P term, maybe one of the reasons why you've got this movement here at zero throttle is because it's only the P term that's responding, and the I term is not helping to counteract that accumulated error. So this may be a very interesting example of the difference between having an idle up switch, which idle up would prevent the I term from, see the I term is zeroed out here? That's because you're below min check on your throttle stick, and that's how Clean Flight does it. But if you had an idle up switch, your stick would never go below min check. Idle up would prevent that. The I term would still be active, and I'll bet some of this floppiness here would be more stable. So very interesting there. How's your general tune here? Anything interesting here? Yeah, another. I don't see any oscillation on the P term here, so that feels pretty good. And D term. I mean, your D gain is 15, so I wouldn't expect D term to really be doing it. I wouldn't even really look at D term because with a D gain of 15, it's probably not doing anything crazy. We got some sort of punchiness here on the P term, but nothing that looks too bad. So I think your P gain is about right. Can we get do we have any flips in here? I don't know. We probably do, and I apologize if I end up missing them. Let me see if I can find a flip for you. Not so much. Nope. Nope, I don't think there's one. Well, anyway, there might be one in one of the other logs, but I'm kind of running out of time. So your P gain looks about right on pitch. Doesn't look problematic. Your roll P gain maybe a smidge high. I think it's 1.0, and maybe knock it down to 0.8 and see if that gets better. If you may want to add some TPA, depending on whether you feel like that the oscillations are only happening at high throttle, or whether that you want to try and get rid of some of the P movement during just those rolls and whatever. But honestly, if it flies good, then I wouldn't worry too much about it, and I'll bet it does fly pretty good. And then on yaw, definitely reduce your P gain on yaw. It's way too high. It's unambiguous and clear. There's no way to say anything but that. I'd start with it at around 2 and maybe work it up. I'm guessing it'll be higher than 2, but I'm not sure. So figure out. But it's way too high where it is right now. All right, that's it for that. Thank you for submitting, and happy flying.